You used fire today. You might not have thought about it, but you did. The stove that heated your breakfast, the engine that powered your car, the electricity running through the wires in your walls, all of it traces back to combustion, to the controlled release of energy through burning. Fire is so deeply embedded in every layer of modern civilization that you do not notice it anymore. It is the background hum of everything. But somewhere, a very long time ago, someone encountered fire for the first time. Not in a kitchen, not in an engine. In the wild, standing in front of a burning landscape with no idea what they were looking at, no concept of chemistry, no understanding of oxygen or fuel or ignition temperature, just heat, light, and something moving across the ground that killed everything it touched. And instead of running, or at least not only running, someone eventually figured out how to take it, how to carry it, how to keep it alive. That decision, that moment, might be the single most important thing that ever happened to our species. So how did it actually start? Let's begin with what the ground tells us, because the archaeology of fire is genuinely surprising. The oldest credible evidence of controlled fire use does not come from Homo sapiens. It does not even come from a species that looked much like us. It comes from Wonderwerk Cave in South Africa, where a 2012 study led by Francesco Berna at Boston University found traces of ash, burned bone, and thermally altered sediments dating to roughly 1 million years ago. The evidence was found deep inside the cave, well beyond where a natural wildfire could have reached, which means something brought fire in and kept it going. That something was almost certainly Homo erectus, a hominin with a brain about 2/3 the size of yours, and a body built more for walking than for thinking. Think about what that means for the question of how humans discovered fire. We did not discover it. Our ancestors did. An earlier species of human, one that could not speak, could not write, could not explain to anyone what fire was or how it worked, somehow learned to interact with the most dangerous chemical reaction in their entire environment and turn it into something useful. 1 million years ago. That is not a typo. 1 million. And they were not alone in figuring it out. At Gesher Benot Yaakov in Israel, archaeologist Naama Goren Inbar and her team found evidence of repeated habitual fire use dating to roughly 790,000 years ago. The evidence includes clusters of burned flint, charred wood, and seeds, and what appear to be heated fish remains, suggesting not just fire maintenance, but actual cooking. Not one fire, not an accident, repeated hearths, used over and over, in the same locations, across extended periods of time. This is not a lightning strike someone got lucky with once. This is a community that understood fire, maintained it, and used it as a regular part of daily life hundreds of thousands of years before our species even existed. But here is the part that changes the story entirely. There is an enormous difference between keeping a fire alive and making one from scratch. And for hundreds of thousands of years, possibly longer, early humans almost certainly did not know how to create fire. They harvested it. Lightning strikes, wildfires, volcanic activity, these natural events provided the initial spark, and hominins learned to scavenge from the aftermath the way they scavenged meat from predator kills. A smoldering branch from a wildfire could be carried back to camp. Coals could be kept alive overnight in a bed of ash. Fire could be transported, nursed, maintained, and passed from group to group across generations. But if it went out, if a storm extinguished it, or someone failed to feed it through the night, it was gone. And you waited, possibly for weeks or months, until nature provided another one. Now imagine the pressure that creates. Your entire group depends on a single flame that cannot be allowed to die. The person whose job it was to keep that fire going was not a minor figure. They were arguably the most important person in the community. Lose the fire, lose the heat, lose the protection from predators at night, lose the ability to cook food. Everything depended on that flame. Everything. So when did someone finally figure out how to make fire from nothing? The earliest archaeological evidence for deliberate fire creation comes from Barnum in Suffolk, England, dating to roughly 400,000 years ago. Researchers found fragments of iron pyrite, a mineral not naturally occurring at the site, meaning someone carried it there on purpose, alongside fire-cracked flint. Strike pyrite against flint and you get a spark. That spark, caught in dry tinder, becomes fire. This is percussion-based fire starting, and it represents a cognitive leap that is genuinely hard to overstate. Someone looked at two rocks and figured out that striking them together in a specific way could produce the same force that had previously only come from the sky. They reverse engineered lightning using rocks. And every fire starting method that followed, the hand drill, the bow drill, the fire plow, the fire piston, every single one of them is a variation on the same basic insight. You can create heat through concentrated repetitive force, and if you apply enough of it to the right material, it ignites. And here is where the story of fire becomes the story of what fire did to us. Because fire did not just change what humans could do, it changed what humans were. In 2009, primatologist Richard Wrangham at Harvard published a book called Catching Fire: How Cooking Made Us Human. The argument he made in it is one of the most compelling ideas in evolutionary biology. Wrangham argued that cooking, specifically the application of fire to food, was not just a convenience that early humans stumbled into. It was the driving force behind the evolution of the modern human body and brain. The logic is straightforward. Cooking breaks down the cellular structure of food, denaturing proteins and gelatinizing starches, making nutrients dramatically easier to absorb. A cooked potato delivers roughly 30% more usable energy than a raw one. Cooked meat yields significantly more calories than raw meat of the same weight. For a species that was constantly on the edge of caloric deficit, that difference was not marginal. It was transformative. The extra energy unlocked by cooking went somewhere specific. It went to the brain. The human brain consumes roughly 20% of the body's total energy at rest, an absurd proportion for an organ that weighs about 1.4 kilograms. No other primate comes close. Wrangham's argument is that cooking provided the caloric surplus that made growing a larger, more energy-hungry brain biologically viable. At the same time, because cooking does much of the work that teeth and guts used to do, our jaws got smaller, our teeth got weaker, and our digestive tracts shrank. We traded gut for brain, and the trade was powered by fire. Think about what that means. The thing that makes you capable of understanding this sentence, the organ that allows you to plan your day, remember your childhood, imagine something that does not exist, that organ exists in its current form because someone figured out how to cook a meal over a fire a very long time ago. Fire did not just keep us warm, fire made us smarter. Think about that next time you turn on your stove. Now, critics of Wrangham's hypothesis point out a real problem. He needs habitual fire use to start nearly 2 million years ago to explain the anatomical changes in Homo erectus, but the definitive hearth evidence does not become widespread until much later. Some researchers favor the idea that increased meat eating and improved stone butchery tools drove brain growth before cooking did. The debate is ongoing. But what nobody disputes is that once cooking became regular practice, it transformed the human body and the human brain in ways that cannot be reversed. We are, at this point, a species that is biologically dependent on cooked food. Try eating raw meat and raw tubers exclusively for a month and see what happens to you. Actually, do not do that. The point is, we cannot go back. Fire changed us permanently at the level of our DNA, and we are still living inside that change every time we eat a meal. And fire did something else while it was reshaping our biology. It kept us alive at night. This is not a small thing. For 99% of human history, darkness was genuinely dangerous. Not metaphorically dangerous. Not the kind of dark where you stub your toe on the coffee table. The kind of dark where a cave lion weighing 300 kilograms is moving through the grass 50 meters from where your children are sleeping. And the only thing standing between your family and that predator is a ring of flame. Anthropologists studying modern hunter-gatherer groups have documented that people who wander away from the fire at night are significantly more likely to be killed by predators, even today. Fire was not a comfort. Fire was a perimeter defense. It was the first security system humans ever had, and for hundreds of thousands of years, it was the only one. But fire did something else that might matter even more than the calories or the brain size or the predator defense. Fire gave us the night. In 2014, anthropologist Polly Weissner at the University of Utah published a study in the Proceedings of the National Academy of Sciences examining how firelight changed social behavior among the Jew Hoansi, a sand community in the Kalahari Desert. Weissner recorded and analyzed hundreds of conversations, comparing what people talked about during the day with what they talked about at night around the fire. The difference was stark. Daytime conversation was practical. Complaints, logistics, immediate social problems, who did what, who owes whom. Standard operational chatter. But at night around the fire, the entire character of conversation shifted. People told stories, They sang. They discussed the spirit world, other communities, the movements of animals and people across large distances. They performed ceremonies and dances. Firelight conversation was almost entirely about imagination, about things that were not immediately present, about building a shared understanding of the world that extended far beyond the campsite. Before fire, the day ended when the sun went down. You slept, or you sat in the dark hoping nothing found you. Fire extended the usable day by hours, and those extra hours, protected by the warmth and light of the flames, became the space where human culture was born. Storytelling, music, religion, the transfer of complex knowledge from one generation to the next. All of it happened around a fire, in the dark, with faces lit by something that no other species on Earth had ever controlled. Fire gave us the night, and the night gave us everything that makes us human. Now, one of the most sophisticated relationships any human culture has ever had with fire belongs to Aboriginal Australians. And it is not even close. In 1969, archaeologist Rhys Jones coined a phrase that would reshape how scientists understood the Australian continent. He called it fire stick farming. Aboriginal Australians were not just using fire to cook food or scare predators. They were using fire to manage an entire continent. For at least 50,000 years, Aboriginal communities conducted systematic, low-intensity burns across the landscape. Not wildfires, not destruction. Controlled, deliberate, carefully timed mosaic burns that cleared undergrowth, promoted the growth of specific food plants, prevented the accumulation of fuel that would otherwise feed catastrophic wildfires, and created fresh green growth that attracted kangaroos and other game directly into hunting range. Palynologist A.P. Kershaw's analysis of pollen records and sediment cores confirmed that these burning practices altered Australian vegetation patterns continuously for tens of thousands of years. Australia, when Europeans arrived, was not an untouched wilderness. It was a managed environment, shaped by fire, maintained by fire, sustained by fire for longer than any civilization in Europe or Asia had existed. The tool was fire, the technology was knowledge, and the people who wielded both had been doing it for 50 millennia. And here's where the story takes a turn that needs to be addressed directly, because a myth about fire and indigenous people has persisted for decades, and it is wrong. In the 1970s, the same Rhys Jones who coined the term fire stick farming made a very different and far more controversial claim. He argued that the indigenous Tasmanians, separated from mainland Australia by rising sea levels roughly 10,000 years ago, had undergone what he called a slow strangulation of the mind. Jones claimed that Tasmanian Aboriginal people had lost multiple complex technologies during their isolation, including, most dramatically, the ability to create fire. According to Jones, Tasmanians could only carry embers from naturally occurring fires and could not ignite new ones. If their fire went out, they were helpless. The image this painted was of a people in cognitive and cultural decline, a population slowly losing the capacity for innovation, drifting backward through thousands of years of isolation. This claim was wrong. And the reasons it was wrong tell you something important about how colonial assumptions distort scientific interpretation. Historians and scholars including Rebbe Taylor, Jim Allen, and Ian McFarlane have systematically dismantled Jones's thesis. Taylor, in her detailed examination titled The Polemics of Making Fire in Tasmania, demonstrated that Jones relied on ambiguous, poorly interpreted colonial-era records. The European observers whose accounts Jones cited were often brief visitors who did not speak the local languages, did not understand what they were seeing, and brought with them a set of assumptions rooted in 19th century racial hierarchy that already classified indigenous Tasmanians as primitive. When these observers did not personally witness fire-making in the narrow window of their visit, they assumed it could not be done. That logical leap tells you far more about the observers than about the people they were observing. Here's what makes this worse. Jones's thesis did not exist in a vacuum. It echoed a much older tradition of European colonial thinking, social Darwinism, which ranked human societies on a linear scale from primitive to civilized, with Europeans conveniently placed at the top. Within that framework, the Tasmanians were already classified as the most primitive people on Earth, a label that had been applied to them since the earliest colonial contact. Jones's claim that they had lost fire-making ability slotted perfectly into that pre-existing narrative. It confirmed what colonial ideology already assumed, that isolated non-European peoples were inherently less capable, less inventive, less human. The science, such as it was built on top of a conclusion that had already been reached before anyone looked at the evidence. The reality is that Tasmanian Aboriginal people lived successfully in a demanding environment for over 35,000 years before European contact. They managed their landscape with fire, harvested resources from both land and sea, developed specialized watercraft, maintained complex social and ceremonial systems, and survived conditions that would have killed any European expedition dropped into the same environment without modern equipment. They adapted to ice age conditions, to rising sea levels that cut them off from the mainland, to shifts in climate and ecology that reshaped their world multiple times over millennia. The idea that these same people, the people who survived all of that, could not figure out how to start a fire, one of the most fundamental human technologies on Earth, while simultaneously managing every other aspect of survival in a challenging environment, does not hold up under any serious scrutiny. The current scholarly consensus flatly rejects Jones's degeneration theory, recognizing it for what it was: a hypothesis shaped more by colonial-era assumptions about racial capability than by actual evidence. And this pattern, Europeans arriving somewhere and fundamentally misunderstanding what they were looking at, repeats itself across the world wherever fire was involved. When European colonizers arrived in North America, they described vast, park-like forests with widely spaced trees, open meadows, and abundant game. They called it wilderness. They called it pristine. They were wrong. What they were looking at was a landscape that had been actively managed by indigenous peoples for thousands of years, and the primary management tool was fire. Native American communities across the continent used controlled burns to clear undergrowth, promote the growth of food-bearing plants like oak and chestnut, maintain open grasslands for hunting, and prevent the dangerous buildup of dead wood and brush that fuels uncontrollable wildfires. The Karuk and Yurok peoples of what is now Northern California burned to encourage the growth of hazel, a plant they used for weaving baskets so tightly constructed they could hold water. The Haudenosaunee in the northeast burned to create meadows for deer and to maintain the open forests that made travel and hunting possible across vast territories. In the Great Plains, indigenous peoples used fire to drive bison herds toward specific kill sites, controlling the movement of animals that outweighed them by a factor of 10 through the strategic application of something those animals instinctively fled from. Fire was not a blunt instrument. It was precision. Different burns at different times of year produced different results, and the people managing those burns understood the timing, the wind conditions, and the ecological consequences with a depth of knowledge that modern forestry is only beginning to appreciate. The forests were open and park-like because they had been burned on purpose regularly by people who understood exactly what fire did to a landscape and used that understanding with extraordinary precision. When those people were removed from the land through colonization, disease, and displacement, the burning stopped. Dead wood accumulated, brush grew thick, and the catastrophic megafires that now burn through millions of acres of North American forest every year are, in significant part, the direct result of a century of fire suppression policies that replaced thousands of years of indigenous fire management with the profoundly misguided assumption that all fire is bad. Today, agencies like the U.S. Forest Service are slowly, belatedly, beginning to reintroduce controlled burning, often in direct collaboration with indigenous communities who never forgot how to do it. The knowledge survived, even when the people carrying it were nearly destroyed. The same story played out in South America with an even more surprising twist. In the Amazon rainforest, archaeologists have found patches of extraordinarily fertile soil called terra preta, dark earth. These soils, scattered across the Amazon basin, are rich in charcoal, organic matter, bone fragments, and pottery shards, and they are staggeringly productive. Plants grown in terra preta dramatically outperform plants grown in the surrounding natural soil. For decades, scientists assumed the Amazon was a pristine, untouched jungle. The terra preta told a completely different story. Ancient Amazonian peoples, in populations far larger than anyone had previously estimated, had used a technique researchers now call slash and char. Unlike the destructive slash and burn practiced by modern settlers, Ancient Amazonians burned organic waste at low intensity and low oxygen, creating biochar that they mixed into the soil alongside bone, pottery fragments, and compost. The result was a soil so fertile that it remains productive today, centuries after the people who created it were wiped out by European diseases. Fire, used intelligently over generations, had literally built the ground these people lived on. In Mesoamerica, fire was central to the Milpa system that sustained civilizations across what is now Mexico and Guatemala, controlled burning, cleared land, and returned a pulse of nutrients, potassium, calcium to the soil for growing maize, beans, and squash. And fire carried ceremonial weight that went far beyond agriculture. The Aztecs performed the new fire ceremony every 52 years to mark the end of a calendrical cycle, extinguishing every flame in the empire and relighting them from a single new fire drilled on the chest of a sacrificial victim on a mountaintop outside Tenochtitlan. The renewal of fire was the renewal of the world itself. For the Maya, oak cock, or fire-entering rituals were performed to consecrate temples and sacred spaces. Fire was not just a tool in the Americas, it was woven into the structure of civilization itself. Now, one of the things that makes fire so remarkable as a human technology is how many completely different methods people invented to create it. And the variety is not random. Each method tells you something about the environment, the available materials, and the ingenuity of the people who developed it. The hand drill is probably the oldest and most widespread. A straight wooden spindle, rotated rapidly between the palms, pressed down into a hearthboard until the friction generates enough heat to form a glowing ember in a notch cut into the wood. It sounds simple. It is brutally difficult. Anyone who has tried it knows that it requires not just the right technique, but the right wood, the right moisture level, the right tinder, and enough sustained physical effort to push well past the point where most people would give up. Your hands blister. Your arms burn, the spindle slips, and if the wood is even slightly damp, you can spin for an hour and get nothing but sore palms and frustration. The fact that people all over the world mastered this and taught it to their children tells you something about the determination of every generation that came before yours. The bow drill added a mechanical advantage by wrapping a bow's string around the spindle, allowing the user to spin it faster and with less fatigue using a back-and-forth pulling motion instead of the downward palm roll. The Inuit used bow drills in the Arctic, where starting a fire with wet frozen materials in temperatures that would kill an unprotected human in hours required equipment that could generate heat quickly and reliably. Some Inuit bow drill sets were made from driftwood and sinew, assembled from whatever the Arctic provided, and they worked in conditions that would make most modern survival gear useless. Ancient Egyptians also used bow drills, and depictions of the tool appear in artwork dating back thousands of years. The same basic mechanism developed independently on opposite ends of the planet, because the physics of friction do not change based on where you're standing. In Polynesia, the dominant method was the fire plow, a technique where a hardwood stick is rubbed rapidly back and forth along a groove in a softer board. The Maori called it hika ahai, and a skilled practitioner could produce flame in under a minute. The technique requires a different kind of physical effort than the drill methods, more like an aggressive sawing motion, and it works best with specific tropical hardwoods that produce fine, combustible dust when abraded. But the most extraordinary fire-starting technology is one most people have never heard of. In Southeast Asia, in what is now Indonesia and the Philippines, people developed the fire piston. The principle is stunningly elegant. A small, precisely machined cylinder, traditionally made from bamboo or hardwood, is fitted with a tight plunger. A tiny piece of tinder is placed in the end of the cylinder. The plunger is slammed down hard with a single sharp strike, compressing the air inside so rapidly that the temperature spikes above 400 degrees Celsius. The tinder ignites instantly. The entire process takes a fraction of a second. This is adiabatic compression, the exact same thermodynamic principle that Rudolf Diesel would use to design his engine in the 1890s. Indigenous craftspeople in Southeast Asia figured it out thousands of years earlier, using bamboo and muscle instead of steel and petroleum. A fire-starting tool invented in the jungle became the operating principle for every diesel truck on Earth tonight. And here's the thing that connects all of these stories, from Wonderwerk Cave to the Kalahari, to Tasmania to the Amazon, to the fire pistons of Southeast Asia. Every culture on Earth without exception has a story about where fire came from. The Greeks had Prometheus, the titan who stole fire from the gods and gave it to humanity, and was punished for it by being chained to a rock where an eagle ate his liver every day for eternity. The punishment tells you how the Greeks understood the stakes. Fire was not a gift freely given. It was something taken, something that cost something, something that changed the relationship between humans and the divine permanently. In Native American traditions, peoples like the Karuk tell of Coyote, the trickster, who saw humans freezing in the cold and organized a relay of animals to steal a burning coal from the fire beings, who hoarded it on a distant mountain. Each animal carried the coal as far as it could before passing it to the next, until finally it reached the people who needed it. The story is about cooperation, about sacrifice, about the idea that fire belongs to everyone and hoarding it is a kind of evil. Aboriginal Australians have dreamtime stories in which ancestral beings guard or spread fire across the land. And in parts of northern Australia, there are real birds, black kites and whistling kites, that have been observed picking up burning sticks from wildfires and dropping them ahead of the fire line to flush out prey. Aboriginal peoples call these birds firehawks, and they appear in oral traditions that may be thousands of years old. A fire story based on something that actually happens, an observation of the natural world so precise that Western science did not formally document it until 2017. Every one of these myths from every continent treats fire as the dividing line. Not tools, not language, not shelter, fire. The thing that cooks the food, the thing that lights the dark, the thing that holds the predators back and draws the family in, the thing that turned a clever ape into something the world had never seen before. Tonight, you will probably turn off a light before you go to sleep. You will press a switch and the room will go dark. You will not think about it. But that light was fire. The electricity that powered it was generated, somewhere, by combustion, by the same chemical reaction a hominin first carried out of a wildfire a million years ago. The heat in your walls, the fuel in your car, the glow of your screen, all of it is fire. Transformed, converted, disguised. But fire, we never stopped needing it. We never stopped depending on it. We just stopped noticing. And the person who first reached into a dying wildfire and pulled out a burning branch, the person who first struck pyrite against flint and watched a spark catch, that person did not have a name that survived. But every single thing you did today, every meal, every journey, every lit room was a direct consequence of that moment. An ape looked at the most destructive force in nature and thought, I can use that. And somehow across a million years, that thought is still keeping the lights on.